Today, if you are preparing for the chemistry practical exam, we have a good news for you. So the good news is that we are going to show you how you will be able to get the correct concentration in mole per dm cube of the acid from the information given. So based on what the information given, we have that relative density of the acid is 1.84 and the purity, that's the percentage purity, is 98%, while the volume you are to add to 1 dm cube of the 1 dm cube volumetric flask is what? 5.6 cm cube. So today I'm going to show you how you can determine the real concentration of this acid. Now, with this information given to us, I'm going to show you this, and I want to encourage you to stay and watch the end, because at the end of the day I will show you also how to get the theoretical value, the volume of the acid that's given to you. Now let's quickly look at this. Based on what we have, I said that this one is relative density, percentage purity, which is 98%. We have 1.84 relative density, and then this is the volume. Now, what does this thing mean? What this thing, relative density, when you look at that, the relative density, what it simply means is that for 1 cm cube, in every 1 cm cube of what? Tetraoxosulphate acid, it contains what? 1.84 grams. That is what it means. Now, what will 1000 contain? We're going to find out what 1000 cm cube will contain, which is equivalent to what? 1 dm cube. Is that okay? So I believe we are together in this. So for the 1000, what it will contain will be 1.84 times 1000. That will give us something that will look like this: 1 grams. That's what we get. 1840 grams, 1840 grams. That is a 1 dm cube of that solution. So what else are we going to do? Now we have the grams, we need to find the percentage purity. That's where this one will play a role. Now the percentage purity of the acid. What we do here now, we have purity percentage. So what we have here, I'll say that this is 98%, which means in these grams now, 1000 cm cube we are talking about, it means that 98/100 times 1840 grams. That will give us, let's quickly do that. It will give us 98 times 1840 divided by 100. We have, what we have will be 1803.2 grams. That's what we have as pure tetraoxosulphate acid in this 1 dm cube. So what next? We have this. Now the next we are going to find out is the what? Molarity. The molarity, or the concentration, perhaps you can say concentration in mole per dm cube, the molarity of this very acid. Now what we have there, since we know that mass, molarity or mole is what? Mass over what? Molar mass. Let's go by that, molar mass. So what we have our mass to be what? 1803.2, which is mass is equal to 1803.2 grams, and then the molar mass of the acid, tetraoxosulphate acid, molar mass of it is equal to 98 gram per mole. 98 gram per mole. So using this formula now, what we are going to do here will be mole is equal to 1803.2 divided by 98. If we divide by 98, what we get will be 18.4 mole. 18.4 mole. So that is just the beginning. That's just the beginning of it. So we've been able to get the number of moles in this in the acid, in 1000 cmp of the acid. So the next thing we are going to do now is that based on what we are given, where the volume will play a role, we have the volume now that we're going to be using. This volume that we're going to be using now. Let's see how we're going to see how we're going to work on it. So we have 18.4 mole. 18.4 mole. This 18.4 mole, what else are we going to do now? We are going to be. This one is not even writing very well. Good. I don't need this thing now. So we have 18.4 mole. Mole per, I say per dm cube of the acid. So let's go back to what we are doing. 18.4 mole. Oh, God. 18.4 mole per dm cube. I believe this thing is visible. So what next are we going to do? Now we're going to be using dilution formula. Dilution formula, which is C1V1 equal to C2V2. Now based on this, this is the formula we normally use in dilution. So from here, our C1 now is 18.4 moles, and then our V1 is what? 5.6 cm cube. This one we have here, and then the volume we need, because we need to convert it. The V2 is the volume we need, which we need to convert to what? 1000 cm cube. We need to dilute it to 1000 cm cube. So now what else? We have the concentration. We don't know this concentration, which is the one we are calculating at this point. So now we have this. We are going to be substituting using this very formula which we have here. So in this formula now, what we do? What we're going to do now, if you substitute, we have 18.4 times 5.6 equal to C2 times 1000. So if we make C2 the subject of the formula, we'll have 18.4 times 5.6 all over 1000. So what we get, what are we going to have when we do this? What we get will be what? 18.4 multiplied by 5.6 divided by 1000. So what we get, the value, the final value, the concentration here will be 0.13103. Let's just leave it here. Mole. That's mole per dm cube. Mole per dm cube. So the concentration of the acid in question is this. So now, how do we get the other one? The volume that will dilute, that will react with the base. That will react with the. Actually, I will be giving you one of the ways of doing this. One of the methods of doing this will be. One of the methods of doing this, we can use our value, our formula CaVa all over what? Cb, and then Vb, and then the mole ratio. This is the mole ratio. This is the formula we can use for that. So using this formula, Ca, our Ca is 0.103. Our volume is unknown, and then the volume of this, remember the grams is what? 4. Sodium hydroxide, the grams of sodium hydroxide is what? 4 grams. Now, molar mass of sodium hydroxide, is 40. So if it's so, to get the molar concentration of this sodium hydroxide will then be 4/40. That will give us 0.1 mole per dm cube. So in that case, we'll substitute it here. We have 0.1 times 25 because that's the volume we normally use in most cases. Now, from the balanced chemical equation where we have the acid reaction, we know that 2 moles of the base will react with the acid. That means the mole ratio there will be what? 2/1. This is 1, this is 2. So what do we do next? We cross multiply. If we cross multiply this, we will have Va times 0.103 times 2 equal to 0.1 times 25. So Va will then be 0.1 times 25 all over 0.103 times 2. So 0.1 times times 25 divided by 0.13 divided by 2. So our final value here will be 12.13 cm cube. That's our volume. That's the theoretical volume. Well, what happened in this that this volume might vary because of the condition of the titration. Maybe when you are unable to get some things in place, you might not be actually getting exactly this. But it means that with this in place now, it has already told you where your possible volume is likely to fall into. That is the endpoint. The volume of the endpoint is going to fall into. So I believe that this has been very helpful to you. And if this thing has been very helpful, as I stated, as I believe, I will encourage you to subscribe to our channel if today is your first time, and share. If there's any question, you leave in the comment section. I will always attend to you. And thank you and goodbye. More of this is coming up. More of this is coming. We have to be getting you more updated. We're going to be doing the volumetric analysis, the calculation, our possible question that is likely to come out. We're going to be looking at it. We also look at the SWOT analysis. We're going to show you all the possible analysis that you're going to see in that. Thank you so much.